Assalamualaikum and good day. In this video, we are continuing on heat treatment of ferrous metal. In the earlier part, we already learned on introduction to heat treatment of ferrous metal. After that, we learned on the first type, which is annealing. The second type is normalizing, and the third type is spheroidizing. The similarity of these three types are after the heat up process, they are being slowly cooled down. But on this next heat treatment, which is quenching or hardening, we will look at the process where the cooling down process is done rapidly, or mean the cooling down process is fast. Without further ado, let's take a look on quenching or hardening heat treatment. Quenching or hardening is the act of rapid cooling of alloy from an elevated temperature to harden the steel in any quenching media. Hardening of steel done to increase the strength and wear resistance. The quicker the steel is cooled, the harder it would be. The process of quenching and hardening is we start by heat up 30 degrees Celsius to 50 degrees Celsius above the upper critical temperature or above A3 line, and then we quench it down. Quench means rapid cool it down. The microstructure produced is Martensite. When we heat up above the upper critical temperature and then we let it be at certain duration, the microstructure change into gamma austenite. And then when we quench it down or we rapid cool it down, it will transform directly into martensite. We already learned this on TTT diagram. As you can see in this cut off TTT diagram, the material being changed into fully austenite or in FCC crystal structure, and then rapid cool it down until it changed directly into martensite. When we compare fine pearlite and martensite, the biggest difference are their hardness. Fine pearlite is softer than martensite, or we can say as martensite is much harder than fine pearlite. The steel shown in blue can be heat treated to harden them by hardening. For example, over here we have medium carbon steel and high carbon steel. Other than that, we have low alloy steel and high alloy steel, stainless steel and tool steel. Why low carbon steel cannot be hardened by hardening process? It is because the carbon content of low carbon steel is less than 0.4%. It will not affect even though we do hardening process on them. So the hardening process is the best for high carbon steel or metal with high carbon content. The temperature for hardening depends on the carbon content. Plain carbon steel below 0.4% will not harden by heat treatment. The temperature decrease from approximately 820 degrees Celsius to 780 degrees Celsius as carbon content increase from 0.4% up to 0.8%. Above 0.8%, the temperature remains constant at 780 degrees Celsius. Hardening temperature same as that for normalizing. To produce microstructure of martensite throughout the cross section, need to consider. The first one is composition of the alloy, type and character of quenching medium, Geometry of specimen. For composition of alloy, higher carbon content give higher hardenability. Alloying element give higher hardenability compared to plain carbon steel. There are several types of quenching medium. Different type will give us different characteristics of quenching. There are 4 commonly used quenching media. The first one is brine, which is salt solution. This medium has the fastest cooling rate. It means that it can cool down our metal very fast. When the cooling rate increases, the hardness of our material also increases. The second medium we have water. It has moderate cooling rate. The third one we use oil. It is the slowest cooling rate. The fourth one we have gas. It is used in automatic furnace. Usually liquid nitrogen can be very fast cooling. The rapid cooling can cause cracking in complex and heavy section. Please pause this video and read on several types of cooling medium that we use. Over here we have water, oil, and air. They have their own characteristic and their advantages and disadvantages. Water will give bigger impact on our quenching process compared to oil, and oil will give bigger impact on our quenching process compared to air. During annealing, material is cooled in air or in heating furnace itself. For hardening, material is immersed in water or oil in order to make it cool very fast or faster than air. For quenching or hardening process, effect of geometry is also important. When the surface to volume ratio increases, the cooling rate increases, the hardness also increases. For example, when we have cylinder-shaped steel bar, lower the diameter size of our cylinder-shaped bar, the harder it will get after we quench or harden it using the same method. The same method means we are using the same medium. Please pause the video so you can read on effect of heat treatment and compare between annealing, normalizing, and hardening or quenching. You can also add these properties or characteristics into the table that I asked you to do. That's all a little bit on hardening or quenching heat treatment. We will meet again in the next video on tempering heat treatment. Thank you. Have a nice day.